let's look at how to take the derivative of exponentials. Now our first one is the easiest one we will ever see. The derivative of e to the x is just e to the x. Normally we have to work a little bit harder than that though. So if we have e to any function of x power, we will still have e to that same power as part of our answer, but then we will also have to multiply by the derivative of that exponent, whatever it may be. Now most of the time our base is going to be e, but every now and then we will have some other generic base, which I'll write as just a. Now once again, whatever that original question is, that is still part of our answer. We're going to see that for all of these. But then we will also multiply by the natural log of that base a. My fourth and final rule here is really a combination of rules 2 and 3. So I've got a to the power of f of x. So you'll notice that a to the f of x is still part of my answer. Again, the original question will always be part of my answer. Like number 2, I also need to multiply by the derivative of the exponent. And like number 3, I also need to multiply by the natural log of that base a. So those are my exponential derivatives. So let's see what they look like. So if I've got 3 times e to the x, well that 3 out in front is just a constant, and e to the x is just e to the x. So this is just 3 times e to the x. In this section, we will see problems where the answer is pretty much exactly the same as the question. That will happen, so don't panic if it does. Now what if we've got e to the 5x power though? So again, I'm going to repeat my question, and then I multiply by the derivative of the exponents. So what is the derivative of 5x? That is just 5. Now generally, I'm going to put that 5 out in front just to make it a little easier to read, but that is our answer. Now let's say we forget about that and do it for all of our problems. For the first one, if I multiplied by the derivative of the exponent, well, the derivative of x is just 1. So even if I multiplied by that, my answer would still be the same. All right, let's do one example as well where we've got that non-e base. So again, in my answer, I've got the exact same thing as my question. Then I'm going to multiply by the derivative of that exponent, and I multiply by the natural log of the base, which in this case is 10. Well, oops, that should be a bracket, parenthesis. Well, that derivative is 2. I'm going to put that 2 natural log of 10 out in front since it is a constant, and then I've got 10 to the power of 2x plus 3. Do you note there's really nothing I can simplify there? If I'd had another constant out in front, I might have been able to simplify it with this too. But generally for these problems, you will not be able to simplify that answer. That's as good as it's going to get. And just to look back at the first one, once again, let's say if we forget and do that, if we multiplied by the natural log of the natural log, that is base e, so the natural log of e is 1. So if you're worried about remembering a lot, technically you can just do the 4th rule. You'll end up doing more work than you need to for some of these, but because the other terms will all simplify to be 1, technically that is something you can do. I would usually just look at 2 and 4 separately though. Again, our base is almost always e, although we will see a few problems, particularly in this section, where we will have a non-e base as well. So those are my exponential derivatives.